Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our first lesson on a given Form 3 topic called SURDS. So when it comes to SURDS, there are a few things that you need to remember. The first one is the property that involves difference of two squares, which states that if you have A then plus B, then you are multiplying with A minus B. This one should always give you A squared then minus B squared. So this is a property that you learned in Form 2. The other thing you need to note is that when you have 1 divided by the root of A, then the conjugate of this particular number will simply be its denominator. So the conjugate will be the root of A, then you also multiply with the conjugate on the numerator in order to rationalize the denominator. So this is going to give you 1 times root A. You are going to get the root of A, then divided by the root of, so this one is the same as saying the root into bracket A multiplied by A. So this is A multiplied by A, which is the same as saying the root of A, then divided by the root of A multiplied by A. You are going to get A squared. Of course, square and the square root will cancel out, so that the rationalized denominator will be the root of A, then divided by A. Then if you also have another number, for example 1 then divided by the root of A, then plus maybe the root of B, then you are told to rationalize the denominator. In this case, the conjugate will be, if it is addition, the conjugate will be minus. So the conjugate will simply be the root of A, then minus the root of B. So it's only the sign that is changing. If it is a plus, it becomes a minus, and vice versa. Then you also multiply the numerator with the conjugate, which is the root of A, then minus the root of B. So this one will give us 1 times root A. You'll simply get the root of A, then minus 1 times root B. You'll still get the root of B, then divided by, for the denominator, I simply use this particular property. I simply take the minus 1, then I square A, then minus B squared. So similar here, the one that is having a minus is this one. So this is the same as saying the root of A squared, then minus the root of B squared. Remember, I'm simply using this property of difference of two squares. So this will be equal to the root of A, then minus the root of B, then divided by, so of course the square root and the square will cancel out. Square root and square will also cancel out. So we remain with A minus B. Therefore, we have rationalized the denominator because there are no surds or roots on the denominator. Then the other case scenario that you can get is if you have 1 then divided by the root of A, then minus the root of B. Now for this case, the conjugate will be the addition. So if it is minus, then the conjugate becomes addition, and vice versa. So the conjugate will be the root of A, then plus the root of B. So plus because here we had minus. Remember, for this case we had plus, the conjugate becomes minus. Then you also multiply the numerator with the conjugate, which is the root of A, then plus the root of B. So this is going to give us 1 times root A. I'm going to get the root of A, then plus 1 times root B. I'll get the root of B. Then divided by, remember on the denominator, this one is still a difference of two squares, because A times B multiplied by A minus B is just the same as saying A minus B, then multiplied by A plus B. It's simply the same thing, because if you take 2 times 4 and you also take 4 times 2, the answers will be the same. This is 8, this is also 8. So it's the same thing for this case here. Therefore, our solution will simply check the one that has minus. So of course it is this one. So this will be the root of A squared, then minus the root of B squared. So this one is going to give us the root of A, then plus the root of B, then divided by, of course the square root and the square will cancel out, square root and square will cancel out, so divided by A minus b. So these are the possible cases when you are finding the conjugate or when you are rationalizing the denominator. Then we can look at a practical example. So let's check our example 1, which reads that simplify into bracket a plus the root of 3, then a minus root 3, hence evaluate 1 over 1 plus the root of 3, correct to 3 significant figures, given that the root of 3 is equals to 1.7321. Therefore, what we are going to do is simply to simplify the first part, which is 1, then plus the root of 3, then of course we are multiplying with 1, then minus the root of 3. So because we are given the value of the root of 3, we are simply going to substitute. So this will be equal to into bracket 1 plus the root of 3. I'm given the root of 3 as 1 point. So this is 1.7321. Then I'm going to multiply with 1 minus the root of 3. So this will be 1 minus the root of 3. I'm given as 1.7321. So this one will be equal to, so 1 plus 1.7321, I'm going to get 2.7321. Then I'll multiply with, if I take 1 minus 1.7321, I'm going to get negative, so this will be negative 0.7321. Then if I multiply these two, 2.7321 times, so let me multiply 2.7321 multiplied by negative 0.7321, I'm going to get negative 2. So this is negative 2.000. Then we have 17041. So if I take this correct to 4 significant figures, it will be negative 2.000. Of course, which can as well be written as simply the negative of 2. So that is the simplified part of 1 plus root 3 into 1 minus root 3. Then we are told hence evaluate 1 over 1 plus root 3 correct to 3 significant figures. So the given part simply needs to be rationalized. We need to rationalize the denominator. So 1 divided by 1 plus the root of 3. This one will simply be equal to, we can actually rationalize the denominator because we are already given the value of this. So the conjugate, because it is addition, it means the conjugate will be plus. So the conjugate will be 1 minus, because this is plus, so the conjugate will be minus 1 over 1 minus the root of 3. Then we also multiply the conjugate on the numerator, which is 1 minus the root of 3. So this will be equal to, of course this will just be 1 times 1, you'll get 1, then minus 1 times 1 root 3, you'll simply get negative the root of 3, then divided by, on the denominator, we are simply going to have 1 plus root 3, then into bracket 1 minus the root of 3, which will be equal to 1 minus the value of root 3 we were given as 1.7321, then divided by, the denominator is actually this particular value here, which has given us a negative 2. So this will be divided by negative 2.00. So this will give me, if I take 1 point, that is 1 minus 1.7321, I'm going to get negative 7. So this is negative 0.7321, then divided by negative 2. So this one should give me, so answer divided by negative 2, I'm going to get positive 0.36605. But I was told to leave my answer correct to 3 significant figures. Remember, a 0 to the left is not significant. Therefore, this is our first significant figure, second and third. So the answer will be 0.36605. 6. So this one is correct to 3 significant figures. Then we look at our second example, which reads that if root 14 divided by root 7 minus root 2 minus root 14 divided by root 7 plus root 2 is equals to a plus root 7 plus b root 2, find the values of a and b, where a and b are rational numbers. Therefore, in order for us to solve this, we'll start by solving the first part of this particular question here. So we'll start by solving, rationalizing this part here. So this will be the root of 14, root 14, then divided by the root of 7, then minus the root of 2. So of course the conjugate will be addition because we have minus in between. So the conjugate will be the root of 7 plus the root of 2. So plus because here we had addition. Then we multiply the same conjugate on the numerator, which will be root 7, then plus the root of 2. So this is going to give me, so on the numerator I'm going to have the following. So root 14 times root 7, this is the same as saying the root of 14, then multiplied by 7, then plus root 14 times root 2 is the same as saying the root of 14 multiplied by 2, then divided by, this is a difference of 2 squares, therefore I'll simply take the root of 7 squared, then minus the root of 2 squared. So this will be equal to, so 14 times 7, 14 multiplied by 7, I'm going to get 98. So this is the root of 98, then plus 14 times 2, I'll get 28, so plus the root of 28, then divided by, so this one will be the square root and the square will cancel out, so that I remain with 7, minus the square root and the square will cancel out, so minus 2. So this one will give me the root of 98, so this is root 98 plus the root of 28, then divided by 7 minus 2, I'm going to get positive 5, so divided by 5. So this is our first part. Then we are going to move to our second part so that we can also work it out. So in our second part of the question, we also need to deal with this one here. So I want to solve this part here. I need to rationalize it. So it is the root of 14, then divided by the root of 7, then plus the root of 2. So the conjugate, of course, will be the minus because it is addition. So the conjugate for this case will be the root of 7, then minus the root of 2. I multiply also the numerator with the conjugate, the root of 7 minus root 2. So this one will give me, this one will be, at the numerator I'll get the root of 14 multiplied by 7, then minus 14 times 2. So this will be the root of 14 multiplied by 2, then divided by, this is a difference of 2 squares, so I'll use this part of minus, so this will be root 7 squared, then I subtract the root of 2 squared, so minus the root of 2 squared. So this will be the root of 14 multiplied by 7, I'll still get positive 98, then minus 14 by 2, I'll get of course 28, then divided by the square root and the square will cancel out, square root and the square will cancel out. So I'm going to remain with 7 minus 2, which will still give me the root of 98, then minus the root of 28, then divided by 5. But remember the question was we were to take the first part, then we subtract the second part. So from the question it was about minus, so it was this part here, then we subtract the second part, so this part minus this part here. So the first part I've gotten the answer as the root of 98, then plus the root of 28, plus the root of 28, then the whole thing divided by 5. Then it was minus, so minus the second part. I've gotten the answer as the root of 98, so root 98 minus the root 28, then divided by 5. So at this point we can find our LCM. Of course the LCM will be 5, then 5 goes into 5 one time, so 1 times this, I'll still get the same number, so this will be 1. 5 into 5, 1, so this will be 1 into the root of 98. So the root of 98, let me write it on the lower side here, that's where I have a lot of space. So this one will be the LCM is 5, so 5 into 5, 1, so this will be 1 into root 98, the root of 98 plus root 28, then 5 into 5, 1, so this will be then 1 times negative, I'll get negative 1 into the root of 98, then minus the root of 28. So this one will give me, of course it will be root 98, then 1 times root 28, I'll get root 28, then 1 times negative 1 times root 98, I'll get negative the root of 98, then negative 1 times negative, I'll get a positive root 28. Then the whole thing is divided by 5. Of course this one and this will give you 0, so we are going to remain with root 28, the root of 28 plus the root of 28, then divided by 5. So remember this one means the coefficient is 1, the coefficient is also 1. Since these are like terms, you simply add directly, so 1 plus 1 you'll get 2. So this will be 2, the root of 28, then divided by 5. Then we can also check if 28 has, let's look at the factors of 28, whether we have one that has a perfect square root. So let me check the roots of 28 here. So by 2, this will be 14, then by 2, I'm going to have 7, then by 7, I'm going to have 1. So we can actually get 4 from here. So this is 4 times 7. So 28 can be rewritten as the root of, so remember it is 2, the 2 roots are 4 multiplied by 7, which can be rewritten as we have 2, then the root of 4 multiplied by the root of 7, which can be written as 2, the square root of 4 is actually positive 2, then we have the root of 7. So this can be written as 2 times 2, I'll get 4 the root of 7. So this will be 4 root 7. But remember the whole thing was divided by 5. So this one should also be divided by 5. So we were told to leave our answer in the form of A. So we were told to leave our answer in this particular format here. So we were told to leave it in this form. So A plus root 7, then plus B the root of 2. But from our final answer, you cannot see the root of 2. Therefore, it means that my final part, I'm going to get this. So in my final part, this is what I'm going to have. So I'm going to rearrange it so that I get, I've started, they want the format of A, root 7, then plus B, the root of 2. So this one will be, I'd write it as 4 divided by 5 root 7. So since I don't have the value of B, it simply means that the value of B is 0. So it is 0 the root of 2, because 0 times the root of 2, the whole term is going to disappear. That is why we remained with this term having the root of 7 alone without the root of B. So if you compare with A root 7, then plus B the root of 2, clearly you can see that the value, hence find the values of A and B. So clearly the value of A will be 4 over 5. So A will be equal to 4 over 5. Then the value of B clearly will be 0. So our B will be equal to 0. So we'll be looking at further examples on the same. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll